grab that? Oh.
I'll go get that. Unless you want to get to
My hands still smell like apple sweets.
Really?
Like the fruits that we eat. So I
had to wash them.
I did, but they like still smell like that.
That's crazy.
Yeah. And that pear, they smell like that pear.
there was a 50% chance we
That's very, very distinct smell.
Yeah.
You're on.
I saw Emily on my last class and I told her about that. I have apple
Oh,
She's like, good luck. You have so much to
No, bro. It's really not that bad.
What's number 19?
What it is, man. Which meal it is? Yeah, my dad has one.
Rory's here. Cooper's here. Lucas G. Maria. I saw Maria earlier. Not now. Lucy still at 6. Xavier and Melissa. Not here. Lucas made it. Melissa made it. Roy made it. Okay, it looks like we've got everybody but Maria. Maria's checked out or something. Okay, guys, we need to finish up what we had started yesterday. So I'd like to start off with the first few minutes, just kind of scanning what it was we were trying to get done in assignment 17, what it was that we did get a chance to get to in assignment 18, and then we need to finish that up so that we can move on to the book assignment. Now the book assignment looks fairly long here, but I think I can do like 75% of that assignment in like 5 minutes. It's going to take you a little bit longer because you're not as used to this as me, but just pointing out that it's not it's not as bad as it looks like. Okay, so in assignment 17, you don't have to get this out if you don't want to. It should be in your binder though. Assignment 17, we talked about what a derivative was. Basically just means slope. If it's linear, that's never been a problem, but as soon as you add curvature, it is a problem. We often talk about this thing called a tangent line, which is a great visual representation of what the derivative is doing. I talked about being careful about the directions here. Sometimes you're just asked for the derivative, sometimes you're asked for the derivative at a point, and sometimes you're asked for the equation of a tangent line. All very similar work. You need the derivative to get the slope at a certain point, and you need the slope at a certain point to be able to write the equation of a tangent line. We looked at that on a calculator. Then the next page we talked about there's two forms of the definition of a derivative, the standard one that I derived for you, and there's an alternate version which is also just the slope formula. We practiced a couple multiple choice where we just tried to do process of elimination to pick out which one had to be true. So again, you don't have to feel great at that at all, just a general idea of what you were supposed to be doing, because I will let you practice that in the future. If we think of slope, anywhere it's undefined, it is no slope, and if there's no slope, there's no derivative. To be differentiable, you have to be continuous. In fact, not only do you have to be differentiable, or to be differentiable, not only do you have to be continuous, which implies these three things we learned in Unit 1, it has to have a slope that exists. So what I mean by that is something like a vertical slope. A vertical line has an undefined slope. So if that slope doesn't exist, his derivative doesn't exist. And we can never take the derivative at a sharp turn, like this. This is referred to mathematically as a cusp. You can't take the derivative at sharp turns. But I can take the derivative basically anywhere else. Anywhere where the slope exists, I can take the derivative. If the slope doesn't exist there, the derivative doesn't exist there, and if there's a sharp turn, to me that also means the slope's not there, because some of you might think the slope was this, some might think it's this, some might think it's this, and it's really none of those. It doesn't exist at that instant. So that is the 10-second review, or 30-second review of what we talked about on assignment 17. What we had time to get to in assignment 18 yesterday was I started giving you some derivative rules. And this is a mix between the power rule and then just introducing you to the first couple that you have to have memorized. Now, when we dig into the practice, you're going to start to memorize them very quickly because, I don't know, like practically every question is going to ask you to do the power rule. Every third question is going to ask you about the derivative of a constant, etc., etc. So, derivative of a constant is 0. We talked about that visually to hopefully help that make sense. We talked about power rule. Sorry, they made me update my OneNote a couple weeks ago, and I'm not used to it, the change. So power rule is just where you bring the power down, lower the power by 1. But one thing about the power rule, and you probably need to add this to your notes right here, is that power rule only works if it's in the right format. You've got to have a number times x to some power. If you have a number times x to some power, you can do power rule. If it's not in that format, you cannot do power rule yet. And there's a few examples on this page that I will clear that up for you. If there's a number out front, I still treat that like power rule. When you bring the 2 down, if there was already a 2, multiply together. Bring the 8 down, if there was already a 3 there, you multiply those together. If its derivatives are separated by add or subtract, do them separately, and then do add or do subtract. Yes, Maria?
Could you just show the format again that you said it has to follow?
Yes. Just trying to center this, but it needs to be a number, any number, times x to some power. It's got to be in that format. So your x can't be in the denominator. You'll see what I mean in just a second. So, okay, and then here's where we ran out of time last time. So we talked about if you want the derivative of multiple terms, you just work the terms separately and then stick the add or subtract sign in between them. If I do power rule to this, what do I get?
4x.
Good. Bring the power down, lower the power by 1. There's already 2 out front, then multiply the 2 by what you brought down. What would the power rule of this be?
24x to the 7.
Very good. And there is a plus sign in between them, so we put a plus sign in between them. If there's a subtract sign in between them, you apply the power rule, slap a subtract sign in between them. Now for limits, add, subtract, multiply, and divide all work that way. Brooklyn, you cannot have your, okay, thank you. I thought you had your phone, I apologize. For limits, add, subtract, multiply, and divide all work this way. With derivatives, only add and subtract works this way. If it's divided by or multiply, we have to do something called the quotient rule or the product rule. Those have formulas to them, and we're going to start looking at that tomorrow. But add and subtract is all that we got with derivatives as far as working out nice and neat. And so something like this, you might have a ton of terms. Doesn't mean the question's any harder. You still apply the power rule the same way. Bring the 5 down, lower the power by 1, do it a second time if need be, do it a third time if need be. However many terms it has is just how many times you're probably going to have to apply the power rule. Doesn't mean that it's a harder question. Okay, good with all that? Okay. And okay, last page, or I think it's last page. No, not last page. Almost last page. Okay, so power rule is the only rule you have to get from this unit. But again, there's some that you have to have memorized. So we talked about the derivative of the constant being 0, and I think that's the only one I've told you so far. So you will also have to know the derivative of all 6 trig functions, but we start off with just sine and cosine. Sine and cosine get used all the time, so you have to see these 2 early. I'll show you the other 4 at some point. But the derivative of cosine is negative sine, whereas the derivative of sine is positive cosine. So they just switch to the other one, but one becomes negative and one does not become negative. And you've got to make sure that you get that straight over time. I'll tell you, even my BC students sometimes mix that up. That's easy to do. But if you had multiple of these in the same question, it really just relies on, if you can do these, you can do these. The derivative of cosine minus sine, you can take the derivative of cosine and then subtract the derivative of sine. You have those 2 memorized, that's it. There's a 3 and a 4 out front. It's just going to make this one 3 bigger and make this one 4 bigger. Now, I left a mistake there for you to try to find in one of those 2 questions. What did I mess up on?
On the second question, it should be a plus sign because the derivative of cosine should be negative sign.
Right. Derivative of cosine is negative sine. So if there's already a negative, this becomes a plus. That's what I'm saying. I'm sure not everybody saw that. It's very easy to mix those 2 up. Sine becomes cosine, cosine becomes negative sine. Okay, we do derivative of exponential functions. This is one of my favorites because it's easy to remember. E to the x is one of very few functions that is his own derivative. The derivative of e to the x is e to the x. If it's 5 times bigger, the slope slash derivative would be 5 times bigger. If you had multiple terms, you get to handle the multiple terms the way I've been doing that the last few questions. This would be 2 times the derivative of e to the x, which is e to the x, minus 5 times the derivative of e to the x. But the derivative of e to the x is e to the x. Easiest derivative you'll ever work with. Yeah.
If there's a number in place of x, would you use the power rule?
So like if it was e to the 7th?
Yeah.
Well, e is a number, and if you take a number to a power, wouldn't this still be a number? Well, what's the derivative of a constant?
Oh, 0.
That would be 0 in that case because it's just a number.
What if you had something like e to the 2x?
If you have something like e to the 2x, your derivative is still going to be, just like this is e to the x, this is going to be e to the 2x. But then there's something called chain rule that we'll get to. That'll be the last thing we do in this unit. You have to come back and multiply by the derivative of the inside. So you have to know to multiply by 2. That's a problem for another day, though. You got to get basic derivatives under your belt. So. Okay, so e to the x is easy. Natural log of x is not bad either. So in calculus, anytime we work with logarithms, 99% of the time it's going to be natural log. They just appear more naturally. So easy to work with, but it's one you have to memorize to be able to survive. Derivative of natural log of x is 1 over x. If you multiply it by 2, it's going to be 2 bigger. Okay, and then to finish up this one, this little section, I'm just going to throw a bunch of these out at you. This is almost like it's kind of snowballing now as review. So what's the derivative of 2 natural log of x? 2 over x. Somebody else, what's the derivative of 4e to the x? 4e to the x minus, so minus. And somebody else, the last part for me.
Negative 8 sine x.
That's it. So again, once you're comfortable with those being memorized, you're just throwing them in there. These are, It's not like there's hundreds of derivatives we memorize. It just feels like it right now because you're seeing them all at once. But okay, and then last derivative one I will tell you, although I'll be honest, we don't use this one very much at all, but it might help convince you that it's really the same thing as this. So if you take the derivative of a logarithm that's not a natural log, it comes out to be 1 over the natural log of the base. So whatever the base is what you take the natural log of, times the thing that you're trying to, never mind, let me say that again. I said that in probably the least efficient way. What you're taking the log of, you get 1 over that thing. So down here, I'm taking the log of x, so I need a 1 over x. Over here, I'm taking the log of x, so I'm going to need a 1 over x. But also times the natural log of whatever the base was. So this one needs a natural log of 3 in the denominator. This one needs a natural log of 8 in the denominator. Again, it's not that this is hard, but I'll be honest, I usually forget this one because we just don't use it very much. I have to kind of relearn at this point in the year. Now, let me apply that over here. So I'm going to do this side first. This would be 1 over x times the natural log of 9. 1 over the thing you're taking the log of times the natural log of the base. But let me do that right here, and then hopefully this helps you understand a little bit of some of the other stuff. If I apply this the same way, I'm taking the log of x, so I could do 1 over x, and the base is e, so I can multiply by the natural log of e. But what is the natural log of e? 1. So what's another way to say log base e of x?
Natural log.
Natural log x. So that is why the derivative of natural log of x is really just 1 over x. It's really the same rule as this, but since this is going to 1, we don't want to have to do that step every single time. We use it too much to do that. Okay, so here's where we can start to actually dive into this. Now, I'm sure I probably said this yesterday. If I didn't, I'm sure I'll say it 100 times over the next month. But typically, the calculus concepts and the calculus steps are usually not that difficult. Anytime you guys complain or think something's hard or you struggle with, 9 times out of 10, it's the algebra behind the questions. So I want you to see that a little bit here, but more I really want you to see it in the last couple questions. So a minute ago, I mentioned that power rule is easy to use, but you better make sure it's in the right format. You need a number times x to some power. If it's not in that format, you better not be trying to do power rule. You're wrong instantly, and all the time you spend on it is not going to help. So this is not written that way. You might be tempted to try to take the derivative of the numerator and then divide it by the derivative of the denominator, but remember I said derivatives don't work that way. Limits work that way, but derivatives don't work that way. So what you have to do is you have to think of a way to rewrite this so that it's in this format. So instead of having x to the positive 2 in the denominator, I'm going to move that up and make it x to the negative 2 in the numerator. Now that's usually uncomfortable for students because you're used to making negative exponents positive, or I hope you are. But for our case, we've got to do that so that it's in this format, and then as soon as it's in this format, the derivative is just a power rule. Bring the power down, lower the power by 1, and the only other step is you need to make this simplified. By simplified, I mean don't leave any negative exponents. X to the negative 3 in the numerator is the same as x to the positive 3 in the denominator. So I had to rewrite it, which can be easy if you're great with exponent rules, but then the power rule is the easy step. Okay, same with this guy. This is not in power rule format, so I need to make this look different. So just like the square root of x is x to the what power? 1/2. Then the fifth root of x is like x to the 1/5. So if you know that, you just have to rewrite it, and now you're ready for the calculus. Bring the power down, lower the power by 1, and simplify your answer by only having positive exponents. Now, strong suggestion, I guess I won't know for a few classes at least, but the habit you probably want to get in to make your life easier as we go through calculus throughout the year. Notice, this is a function, it says f of x. I rewrote it with algebra, but I've not done any calculus yet. This is still a function. The second I do a derivative, I start calling it a derivative. You really want to make a habit of that. Function, I rewrote it, but I didn't take the derivative. As soon as I take the derivative, I start calling it the derivative. Making sure that you label that as you go through. Make your life easier. Okay, and this third one, notice it is also not ready to go for power rule, but we can apply exponent rules. So let me give you an easy reminder. What would x to the 4th divided, or x to the 6th divided by x to the 4th? How would that reduce?
X squared.
Okay, everybody okay? That's x squared. So what you're really doing here is when you divide things with the same base, the base being x, you can subtract the exponents. 6 minus 4 leaves us 2. So I'm going to do the exact same thing here. I'm doing a different color so you can keep up. This is like x to the 1/2 divided by x to the 1st. If I'm dividing things with the same base, I can subtract those exponents. 1/2 minus 1 is negative 1/2. Now that the function is a number times x to some power, now product rule is not going to give me any issues. Bring the power down, lower the power by 1, and before you circle your answer, simplify. And all you can do for simplifying is move the x to the negative 3/2 to the denominator to make it positive 3/2. So this is a quick little taste where everybody can understand power rule, but sometimes if you don't know an exponent rule, or you don't know a radical exponent rule, or you don't know how exponents can move fractions and change signs to get them the way you want it to, sometimes you just won't even let yourself have a chance with the calculus because you may not remember a prior skill. So okay, let's see if I can recover this. Okay, so now we're to the last page. Okay, so last thing I need to tell you about is horizontal tangent lines. So one of the most common things you will be asked to find as soon as you start taking derivatives is horizontal tangent lines. So this made up graph here, I just made up a scenario. We're going to pretend like this graph represents the distance you're away from home at a given time. So if you were right here, where would you be?
Home.
You're at home, right? You've got 0 distance from home. So really he's away from home, and he gets closer to home, he gets closer to home, he gets closer to home, he gets home, then he goes away from home in the other direction, comes back later. But remember, tangent lines are like a visual of the derivative, and horizontal lines have a slope that is 0. So notice there's a few times, a few instances, x equals 1, 3, and 5, where the slope is 0. Notice I'm kind of drawing in a mini tangent line to help you see the slope is 0 at those times. It's almost at x equals 7, but not quite. Well, it depends on what the function means, but those horizontal tangent lines are probably something important. So if this is how far away this person is away from home, what would the horizontal tangent lines mean in the context of that?
Standing still.
Right, that's when he stopped. He's getting closer and closer and closer to home, and then for an instant he stops. So I don't know, maybe he's waiting on a crosswalk or something, who knows. But I know at those instances, that's the time when he stopped and did something else. But some of you someday may own your own business, and this could represent a cost function. You could type in all the data of your customers and all that kind of stuff, and if this was a cost function, you would maybe care about this piece. Because cost, you want to minimize it. You don't want to pay more than you have to. So where your costs keep going down and start going up, that's the point of interest. What was I doing here to have the lowest cost possible? That horizontal tangent line has a real world consequence to it. Or if it's a profit function, you would want to focus in on something like this, because if your profit was going up and then started going down, what did I change here that made it start going down? This horizontal tangent line is a point of interest to me. That's when something happened that changed my business in a negative way. So these horizontal tangent lines typically are just really important parts in the real world, depending on what the function represents. So all horizontal lines have a slope of 0, and then in calculus we just say that they have a derivative of 0. Remember, derivative and slope, basically the same thing. Anytime you need help with derivative, maybe think of slope, and if you need a slope, you probably need to think of derivative. Those words are basically interchangeable to us. Okay, and then finally the last 3 examples I want to give you. This is a second time where I want to convince you, hopefully not scare you, but I need to convince you that typically the calculus is not the hard part. It's previous algebra stuff. And some algebra stuff you're just going to get better at throughout the year, but that tends to be what is the hardest part for students. So these last 3 questions, I want to figure out where they have horizontal tangent lines. So for this guy, horizontal tangent lines are when the derivative is 0. Derivative, which is power rule twice. Set it equal to 0 because they ask for horizontal tangent lines. Now, can you do the power rule? Probably, especially after this book assignment, you'll be able to. Can you memorize that horizontal tangent lines are just when the derivative is 0? Sure, but some of you are going to struggle finishing it. You can subtract the 1 and divide the 3. You can take the square root of both sides, which is plus or minus, and then all of a sudden you have to remember how to deal with the square root of negative numbers. Square root of negative numbers are imaginary. Imaginary doesn't mean they don't exist, that's just what they're called. But imaginary numbers don't show up on a graph, and when we're talking about tangent lines do show up on the graph. So this guy never has any horizontal tangent lines. There's not one instance in that graph where the slope is 0. That graph is going up the whole time or down the whole time, but it's never, even for an instant, horizontal. And I found that from the algebra. Okay, let me do that again with another example with just a different issue. So, what is the derivative of x? 1. You can just do power rule there. Bring the 1 down. 1 times 1 is 1. Lower the power by 1. It becomes 0. X to the 0 is 1. Somebody else, what's the derivative of 4e to the x? Exact same thing. 4 times the derivative of e to the x, which is e to the x. If you wanted horizontal tangent lines, you could set that equal to 0. You could subtract the 1 and divide the 4. I'm going to switch these two just because that's a little bit easier for you guys to see. But all of a sudden, I can do the calculus. I can do the power rule. I can memorize the derivative of e to the x. I can memorize that horizontal tangent lines are when the derivative is 0. And then I still might struggle right here. So this is an exponential, and the only way to solve an exponential equation is with logarithms. That's why logarithms are important. So this would be the same as this. And of course, again, I'm not trying to scare you here. As logarithms come up, logarithm properties come up that you guys need to ask about, you can ask. It doesn't mean that you're not on the hook for them occasionally, but I don't expect everyone to remember everything from every math class you ever had. I'm just trying to point out to you that some previous math things are just going to kind of sneak up like this. So you get that, and then what does this mean, if anything?
X has to be imaginary, which means it never graphs the tangent line.
Right. So this also never has a horizontal tangent line because you can't take the log of a negative number. You can't take the log of 0 and you can't take the log of a negative number. If you happen to know what a logarithmic graph looks like I have over here, you can visually see you can't take the log of 0 and you can never take the log of a negative. So you talked about that at some point in Algebra 2 and maybe pre-calculus, but if you don't remember that, that's where sometimes you can get stuck. I know the calculus, I can solve the algebra, but maybe I don't remember this logarithm skill that keeps me from getting the final answer. And then this one you guys are already aware of, but one last example, to do power rule. I know the derivative of cosine is negative sine because I memorized that. Horizontal tangent lines are when the derivative is 0. So I could plug that in. I could solve for this. And then sometimes, again, this is the one that you've already had some exposure to, but even once you're good at derivatives, and even if you can solve equations, there's still some gatekeeping. At the end of the day, you might still need unit circle to finish this question. Sine is square root of 3 over 2 at pi over 3 and 2 pi over 3. So you can't just say, I'm not good at unit circle, I'll be good at the calculus, because sometimes unit circle is the last step of calculus. You can't just say, I'll be great at calculus, I don't need to remember logarithm properties, because sometimes you've got to know a logarithm property to finish the question. Same with imaginary numbers. If you don't know how to deal with imaginary numbers, sometimes you could be held back for that. But again, this is not like this is going to come up today. I'm just putting these things on your radar. This is really the struggle in semester 1, recalling all this stuff. Okay, so finally, on a blank piece of paper, I'd like you to take a moment to copy the assignment down. Go ahead and just copy it to the top of your page. Now, these are different handouts than I had for you yesterday because I lost too many of them and I reprinted this time. But in general, I can't make unlimited copies. I can't make this many copies for you guys. So I might have to make you use the textbooks in general, but these are not for you to keep. These are just classroom notes. So go ahead and copy the assignment down. Start doing the first couple questions. You'll see how quick they are. They're very fast, or at least the first few are fast. I mentioned at the start of class, when my other classes did it, and the time that I asked them to write this down, and like those 4 minutes that I waited on everybody, I had mentally done like 75% of the time. Like the first question is, what's the derivative of 12? What's the derivative of 12? 0. So there's question 1. Second question, what's the derivative of x to the 12? There's question 2 done. So that's what I'm saying. It looks like a lot, but I promise it's not that bad. So when I need these back at the end of class, I'm going to ask that you just throw them on this basket. That way you can do it on your way out and not have to. So do not keep these. If you don't finish the book assignment in class, which you probably won't, you probably will have a few left for homework. You've got a few options. You can either check out a textbook, like I told you the first few weeks of school. You're always welcome to do that. But I also shared with you in Google Classroom last week an ebook of the entire book. So you can get that off Google Classroom and you can just download the entire book. And then if you have space to keep it on your Chromebook, it's like 50 megabytes, then you just have it anytime you need it. So what I want to offer is I will keep the book handout here with me. So as soon as you get to a question you need help with, please ask, especially since you're having that question, other people are probably also having that question. And I will ask you to finish up these questions for homework. I will ask you to finish up these questions for homework. But if there's some of these you struggle with outside of class, on our class website, I have every single one of these worked. So it's fine if you struggle with question 60 near the end, or maybe you don't understand the directions. That's not a reason to not have your homework finished and ready to turn in tomorrow. Class website, go all the way down to assignment 19. There'll be an individual video just for question 60. So if you need help with that one, just watch that one video. And that way we're all together at the same place tomorrow. Okay, so again, I have the book printout in front of me as well. So the second you get to one that you are not sure about, please ask. And I will discuss it on the board until we run out of time. Sure. Okay.
12. So it's 6x plus 3, and that's just going to go to 9, so would that make
Why
it
would
a
they-
constant?
Why would they go to 9?
Well, I won't.
You can't combine these. These are not like terms.
Well, that's x to the 1. So
Uh-huh.
then,
Okay, so let's do power rule on this term. If you
Yeah.
bring the 1 down, 6 times 1 is still 6.
yeah.
You lower the power by 1, what's x to the 0?
1.
So you get
So
6.
it's still 6, so 6 plus 3 is 9, and then
But
9
wait,
is
wait,
a
wait.
constant.
Why are you taking the derivative of the first term and not taking the derivative of the second term?
How would I take the derivative of the or is that just 0?
That's 0.
So then it would be 6.
Yeah. Now think about this. Doesn't this look like mx plus b?
Oh, yeah.
And the slope is 6? So
Okay.
your derivative is 6.
Okay, it's just 6.
It's just 6. Derivative of 6x is 6, and the derivative of 3 is 0, because the derivative of the constant is always 0. Does anybody else have a question you want me to talk about on the board? Guys, we've got a few minutes left, so let me re-say these directions real quick, just to make sure you don't miss out any points and what you don't hear. So, you should have a few more book questions to finish. If you need to do that between now and tomorrow, I will ask you those next class. If you struggle with any of them, the class website has individual videos for you to watch any that you missed. You cannot take these book handouts with you. I need these back. There's a basket up there that you can put them into. If you want me to check you out a book, I can. If you're fine using a virtual ebook, it's on Google Classroom, that's great. The other option is, you're welcome to take pictures of this with your phone, but if you're gonna do that, you have to wait until after 4:05 and have your phone out until after school's over. So, if this is the last class of the day, I guess that's an option, but I don't know. If I was you, I wouldn't wanna take pictures of all of this. I would just get the ebook off Google Classroom, but I'll leave that up to you. Everyone prefers different things. And we'll talk about topics.
On Academy, I forgot. 0.